let's take a look at an example of a function where we are going to find the limit of the function at a point, and then we are going to prove that the value that we found actually is the limit, right? So here is our function. We have this function f of x equals 3x squared minus 5x plus 2 over x minus 1. We want to find the limit of f at 1. Right? And so we're just going to go through this. We'll roll through it using some basic calculus concepts. So we're taking the limit of 3x squared minus 5x plus 2 over x minus 1. We're taking that limit at 1. We can factor the top factors into 3x minus 2 times x minus 1. And so then those x minus 1's cancel. And we have a limit as x goes to 1 of 3x minus 2. That limit is equal to 1. Right? So that is what we think the limit is. We think that limit is 1. Now we are going to go through and we're going to prove using our definition what the limit of this function is. Right? So we need to show that so let's look back at our definition. Right? So we need to show that for every choice of epsilon greater than 0, there exists this choice of delta such that whenever our x value is in the domain and is less than delta, the distance between x and c is less than delta, then the distance between f of x and L is going to be less than that value of epsilon. So we are going to do that. We will first work through some scratch work when we are trying to come up with this proof, and then we will formally prove that. Right? So let's maybe do some scratch work over here. So this stuff in blue will be our scratch work, right? So we are wanting to think about if we are given epsilon greater than 0, we want to find this value of delta so that whenever we have 0 is less than x minus, our value of c is going to be 1. So whenever we have x is more than, is not the value 1, but it is less than delta units away from 1, then that we want that to force to imply that the distance between our function, 3x squared minus 5x plus 2 over x minus 1. We want the distance between that and 1, the value that we are converging to, our limit, we want that to be less than epsilon. Right? And so the way that we're going to do that is we're going to work through this and see what kind of restriction that's going to put on the absolute value of x minus 1. So we're going to come up with a choice of delta in terms of epsilon. All right, so we want 3x squared minus 5x plus 2 over x minus 1 minus 1 to be less than epsilon. If we go through that, then we can get a common denominator and do some cancellation, but we get 3x minus 2 minus 1. So if we do the cancellation, rather, 3x minus 2 minus 1 is less than epsilon. Right, so we have 3x minus 3 is less than epsilon. We can factor a 3 out of that. And so here is how we are going to choose our value of delta. We are going to choose delta so that delta is equal to epsilon over 3. Right? So when we go through and write the proof, that's not really part of our formal proof writing. This is really just scratch work. It wouldn't really show up anywhere other than in scratch work. But now let's prove that this actually is our limit. And so our proof, given epsilon greater than 0, we are going to choose delta equal to epsilon over 3. So we choose delta equal to epsilon over 3. Then if 0 is less than the absolute value of x minus 1 is less than delta, it follows that the absolute value of x minus 1 is less than epsilon over 3, because that is our choice of delta. And so when we look at f of x, the absolute value of f of x minus 1, that is equal to 3x squared minus 5x plus 2 over x minus 1 minus 1, which is equal to the absolute value of 3x minus 2 minus 1. But we know the absolute value of x minus 1 is less than epsilon over 3, so we have 3 times, this is less than 3 times epsilon over 3. So this function has to be less than epsilon. And we have proven it. We are done with that proof. Perfect. We'll take a look at another example in our next video. We'll talk to you guys later.